Welcome to the Deep Dive. If you're anything like us, you're probably feeling a bit overwhelmed by all the info, all the new tools, especially, in the AI space.
Oh, absolutely. We're talking about these autonomous AI developers now. Agents that can supposedly build an entire complex WordPress theme from the ground up, all by themselves.
But that's the big question, isn't it? How do you actually make sure that what the AI builds is, well, strategic? Something that genuinely hits your business goals, follows all the technical rules, and acts like a professional tool.
And not just some pretty but ultimately hollow experiment.
Exactly. Or maybe not exactly. Because the real insight, the thing that really jumped out from the research we looked at, is that success seems to hinge almost entirely on the quality of your input, your instructions.
It really does. It's garbage in, garbage out, but on a much more sophisticated level.
So our mission today is basically a deep dive into engineering trust. How do you translate those fuzzy desires like, I need a better website, into a super concrete, unambiguous blueprint for an AI collaborator? Something like the Gemini CLI, for instance.
Right. We've sort of broken this down into a 6-part framework for crafting that ultimate prompt. We'll start with the high-level business strategy and go all the way down to the nitty-gritty of the AI agent's own technical setup.
It sounds like the difference between asking an AI to just, paint a pretty picture versus asking it to engineer a bridge.
That's a great analogy. For the bridge, every single specification matters. Precision is everything. So let's unpack this framework. Part 1 has to be the foundation strategy.
Yeah, the sources we reviewed were pretty blunt about this. Something like 90% of web project failures aren't technical failures at all. They're strategic failures.
Exactly. And the biggest strategic mistake, starting with the visuals, thinking about how it looks before you've defined what it does.
We need to get rid of what the research called the strategically hollow theme, that old way of thinking.
Oh yeah, my competitor has one, so I need one too. Mindset. Or just needing a digital brochure. That's completely obsolete now.
Today, a website has to be an active tool, something measurable, designed specifically to hit clear business objectives.
So the very first most critical instruction in this ultimate prompt has got to define the core purpose. This isn't just a vague idea. It needs to be a clear declaration. It sets the AI's entire priority system.
Can you give an example? Like, how does defining that purpose change what the AI does?
Sure. Let's say the core purpose is explicitly stated as generate leads. Okay, now the AI knows it must prioritize things like high contrast call to action buttons. It knows forms need to be prominent, probably above the fold. It needs to minimize anything that might distract from that conversion path.
Okay, and what if the purpose is different? Say, establish brand authority.
Then the AI's focus shifts completely. It's now thinking about showcasing high-quality images or videos, maybe integrating case study sections prominently, ensuring the typography feels authoritative and readable, allowing for denser content, perhaps. The whole build philosophy changes based on that one initial declaration.
So that core purpose acts like an anchor. Every little decision the AI makes later, like which CSS framework to use or how wide a sidebar should be, it has to be justifiable against that main goal.
Precisely. And the instruction should probably even say, if a feature or design choice detracts from this core purpose, eliminate it. Ruthless prioritization.
Okay, makes sense. But a purpose needs an audience, right? You can't serve a purpose without knowing who you're serving.
Exactly. Which brings us straight to user-centered design. And for the AI, this translates into needing a really detailed user persona.
And we can't just give it basic demographics, can we? Like, female, 30-40, lives in the city. That's not enough context.
No, not at all. The research insists on providing both the demographic profile, age, location, yes, but also technical proficiency. Are these users comfortable with complex filters, or do they need big, obvious buttons and simple navigation?
And crucially, the psychographic profile, this is the deeper stuff.
This is where the real insights are. What are their values? What are their interests? What keeps them up at night? Their pain points. Imagine you're building a site for, say, seniors managing retirement funds.
Okay.
Understanding their potential pain points, maybe vision difficulties, maybe anxiety about complex interfaces, directly tells the AI to prioritize things like extreme contrast, large, clear fonts, and maybe a very minimal, non-distracting layout that comes directly from the psychographics.
And then we need to translate those pain points into specific actions the user wants to take on the site, the user goals.
Yes. The AI needs to know exactly what task the visitor is trying to accomplish. Is their primary goal find the nearest store location in under 3 clicks? Or maybe it's easily compare the technical specs of product A versus product B, even on a mobile phone.
Because the theme's success is basically measured by how easily users can complete those specific tasks.
Absolutely. If they can't do what they came there to do efficiently, the theme has failed. Doesn't matter how fast it loads or how beautiful it looks. Which, naturally, leads us to measurement. We have to get past vague goals like improve the website.
Right, that's useless for an AI. This is where the SMART goals framework becomes critical again, but specifically tailored for instructing an autonomous agent.
Specific, measurable, achievable, relevant, and time-bound. Vagueness is the enemy when you're dealing with code generation. The AI needs concrete targets.
And it's usually not just one person's goals, is it? A website serves different groups.
That's a key point. The prompt needs to segment goals for all the key stakeholders because their priorities might even conflict sometimes. The AI needs to understand this landscape.
Okay, so let's break that down. What's the first group? The most obvious one.
Goals for users. These should be purely about improving the user experience, and they must be measurable through analytics. A really good example from the research was reduce the number of clicks required to complete a standard purchase from the current 5 steps down to 3 steps by the end of Q4. This will be measured using our core analytics platform.
That's incredibly specific. No room for interpretation there.
None. The AI knows exactly what success looks like for the user journey. Then, of course, you have the goals for business stakeholders.
These tie back directly to that core purpose we defined earlier, right?
Exactly. They're about organizational outcomes. If the core purpose was, say, brand authority, then a related business goal might be something like increase the average time users spend viewing our technical case studies by 15% within 3 months of the new theme launch.
Okay, that makes sense. User goals, business goals. But the research mentioned a third group, which initially I thought, maybe we could skip this if we're tight on time. And that's goals for content managers. Why are those so important for the AI to know? Doesn't it just need to build the front-end experience?
That's a really insightful question, and skipping this is a classic mistake that leads to long-term pain. We call it technical debt through administrative friction.
Okay, explain that.
If you don't give the AI goals related to the back-end usability, it might build a beautiful front-end but a nightmare back-end that's hard to update. A goal like reduce the time required for a content manager to publish a standard new blog post by 50%, measured 1 month after theme launch, forces the AI to think about the entire workflow.
So it forces the AI to build a clean, efficient, intuitive WordPress admin experience using best practices.
Precisely. It makes the AI consider the total cost of ownership, not just the initial build. A theme that's a pain to maintain becomes a huge liability down the line, no matter how nice it looks or how many leads it generates initially.
Got it. So user goals, business goals, and admin goals. And the way we connect all this for the AI is through something called the translation cascade.
Yes, this is a really powerful concept. You're essentially giving the AI the reasoning behind the instructions. You're showing it the chain of logic.
How does that work in practice?
Well, instead of just telling the AI, build a fast checkout, you lay out the whole thought process. Start with the high-level business need. We need to increase profitability. Okay, how? Translate that to a specific website goal. We need to increase the velocity of online sales. Right? What does that require from a user perspective? A user-centric requirement. Users need a lightning-fast, frictionless checkout experience. And then finally, that translates into the concrete AI instruction. Generate a one-page WooCommerce checkout template that minimizes the number of form fields required and explicitly eliminates mandatory user registration before purchase.
Wow, so you're forcing the AI to understand the why behind the what. It has to connect its code decisions back to that strategic foundation you laid out.
Exactly. It helps ensure the AI doesn't just fulfill the letter of the instruction, but also the spirit of the strategic intent. It builds a validation layer into AI's own process.
Okay, so we've hammered out the strategy, the why. Now we need to get into the what's and the where.
Yeah.
Defining the actual structure and content of the site.
Right. We're moving from that abstract strategic intent to the architectural blueprint. And the absolute starting point for this is the sitemap.
This seems non-negotiable. It's the master plan, isn't it? A hierarchical list of every single page the theme needs to include.
It is. And it serves 2 vital functions for the AI. First, it's the definitive checklist of templates the AI must generate. If a page home, about us, Services overview, specific service subpage, contact, blog archive, single post layout isn't on that map, the AI shouldn't build it. Scope control.
And the second function.
It dictates the primary navigation structure. The parent-child relationships in the sitemap tell the AI how deep the information architecture goes and what the main menu items should probably be.
Okay, sitemap gives us the overall structure. Then we need to zoom in on individual pages using wireframes.
Yes, wireframing key page layouts, and the sources were really strict here. These wireframes must be low fidelity. We're talking basic boxes and lines. Focus only on structure and hierarchy, not colors, fonts, or images. That comes later.
What specific things do these wireframes need to define for the AI?
Two main things. First, the functional regions. Where does the header go? The footer. Is there a sidebar? If so, left or right, just blocking out those main zones.
And second?
The visual hierarchy within those key pages, especially crucial ones like the home page or specific landing pages. This means dictating things like where does the logo sit relative to the main menu? Where does the primary call to action button go? What absolutely needs to be visible above the fold when the page first loads?
So we need to be quite specific in the instructions accompanying the wireframe. Like the main headline must occupy the top 30% of the initial viewport.
Exactly. Or the primary CTA button must be positioned in the top right quadrant on desktop screens and immediately below the main hero image on mobile screens. This removes ambiguity about which elements get priority.
And which page types definitely need a wireframe.
You absolutely need them for your homepage, any key landing pages, like for specific campaigns, a standard content page, like About Us, the single post or single product template, and your main archives pages, like the blog index or product category pages. Those cover the core user interactions.
All right, structure defined. Now, what goes inside that structure? The content, the theme is just the container, right?
Precisely. The content provides the actual value. So the prompt needs comprehensive content requirements. You have to tell the AI what kind of content to expect on each template.
This means detailing everything, like heading structures, body copy.
Yes. For written content, specify the expected H1, H2 structure, maybe the approximate length of body text paragraphs, even the precise copy for key CTAs if you have it. For visual content, define the style, e.g. optimistic, diverse team photos versus technical product close-ups. The quality, high resolution only. Quantity, expect image galleries with 5-10 images per product.
Could even include things like video specs.
Absolutely. Requires a 30-second high-resolution background video for the hero section, must be optimized for fast loading, and provide a static fallback image for mobile devices. That level of detail.
Now, you mentioned something earlier that sounded really key, the placeholder strategy. Getting rid of lorem ipsum.
Yes, this is crucial for making sure the design actually works. When an AI or even a human developer uses standard lorem ipsum text, you simply cannot accurately judge how the typography, the line spacing, the overall layout feels. The design choices are made in a vacuum.
So instead of the AI just putting headline goes here, what do we instruct it to do?
We instruct it to use realistic placeholder copy that reflects the intended length and tone. So instead of headline here, maybe the instruction is, use placeholder copy like innovative cloud solutions for modern enterprise businesses.
Ah, I see. Because the length and shape of that realistic text immediately shows you if your chosen font size works, if the line breaks look okay, if it fits the container properly.
Exactly. It makes the layout and typography choices meaningful from the start. But there's a critical accessibility caveat here.
Okay, what's that?
These realistic placeholders, while great for visual design, must never replace proper semantic label elements for form fields. A placeholder in an input field might hint at the format, like you@example.com, but the label tag itself, visibly linked or available to screen readers, is absolutely essential for accessibility. The AI must be explicitly told this.
Got it. Accessibility first. Okay, content requirements are clear. Now, how do users navigate through all this? We need to define navigation and user journeys.
Right. The goal here is to create a smooth, intuitive path for the user to follow, ideally leading them towards completing those SMART goals we set up back in part 1.
So the primary navigation, the main menu, should pretty much mirror the top level of the sitemap we created.
Yes, absolutely. And the labels used in that navigation need to be crystal clear and conventional. Use contact, services, pricing. Don't get clever with jargon. Clarity trumps creativity in navigation.
And we need to map out the ideal flows.
Yes, that's user journey mapping. We need to explicitly describe the ideal step-by-step path for key tasks. For example, a user reads a blog post related to X. They should see a clear CTA within the content related to product Y. Clicking that CTA takes them directly to the Product Y page, where the Add to Cart button is immediately visible. The theme structure must facilitate that flow seamlessly.
This sounds like it connects to the technical side of WordPress too.
It does, perfectly. This brings us to what we call the template hierarchy bridge. This is maybe a bit technical, but it's fundamental for ensuring the AI builds a theme that actually works correctly within WordPress.
Okay, break it down. What is it?
It's about explicitly mapping the user-facing structure, like the URL slug contact us that the user sees, to the specific technical WordPress template file the AI needs to create and use. For contact us, that might be page-contact-us.php, or perhaps just page.php if it's a generic page template.
Why is making that explicit link so important? Can't the AI figure it out?
Maybe, but maybe not correctly according to WordPress's very specific rules. WordPress has a cascade system for choosing which template file to load based on the context. Is it a page, a post, a category archive, etc.? If the AI just creates a file named contact.php, a WordPress might ignore it entirely. By explicitly telling it, for the page with the slug contact us, you must use the template file named page-contactus.php. We remove all ambiguity and force it to comply with the core WordPress loading logic.
Okay, that makes sense. Removes guesswork. Now, what about when things are empty?
Ah, yes. A truly robust theme handles the awkward silences gracefully. We need to define empty states and edge cases. What happens when a user searches and gets 0 results? What does an empty shopping cart look like? What if a blog category currently has no posts in it?
These are potential dead ends for the user, right? Which is bad UX.
Exactly. So the prompt must instruct the AI on the anatomy of a good empty state. It needs 3 components. First, a clear message explaining what's happening. Sorry, no results found for your search. Second, a simple visual, maybe an icon or a subtle illustration, like a magnifying glass with a line through it. And third, crucially, a clear call to action suggesting the next step.
So it doesn't just leave the user hanging.
Right. For the empty search results example, after the message and icon, the CTA might be a button saying, try searching again with different terms, or browse our popular categories instead. It prevents user frustration and keeps them moving through the site rather than just giving up.
All right, we've got the strategy, the structure, the content plan, even the empty states. Now we can finally talk about the look and feel, the visual identity.
Yes, but always remembering that the design must serve the function and strategy we defined back in part 1. It's not just about making it pretty, it's about making it effective. And the #1 principle here is establishing a clear visual hierarchy.
So using graphic design techniques not just for aesthetics, but to actively guide the user's eye to the most important stuff first.
Exactly. And we need to give the AI explicit instructions on how to create that hierarchy. There are several levers we can pull.
Like what?
First, size. We can give concrete rules like the main H1 heading must always be at least twice the font size of the standard body text. Simple rule, big impact.
Okay, size. What else?
Color and contrast. This is huge. We need to specify that critical elements, especially call to actions, must use a designated accent color that contrasts strongly with its background. We should even reference WCAG accessibility guidelines for minimum contrast ratios here, and maybe specify high contrast for body text, like near black on near white for maximum readability.
Makes sense. Size, color, contrast. What's the third?
Position. We already mentioned keeping vital info above the fold. But just as important is the strategic use of white space or negative space. The research really emphasized this.
How so?
You need to instruct the AI to use ample white space, maybe specifying minimum margins, like at least 60 pixels of vertical space separating distinct functional regions, like header from hero, hero from main content. This white space stops the page feeling cluttered and visually separates elements, making the important ones stand out more clearly. A crowded page makes everything look equally important, which means nothing stands out.
Okay, so visual hierarchy is established. What about the specific colors and fonts? We need consistency there.
Absolutely. This leads to defining the brand palette and typography system. We need to give the AI strict, limited systems to work within. No improvisation allowed here.
So for the color palette, we're talking exact color codes.
Yes. Precise HEX codes for the primary color, the main brand color, secondary for less prominent elements or backgrounds, accent, reserved only for things needing maximum emphasis like CTAs and maybe active links, and neutrals for text, borders, subtle backgrounds.
And not just the codes, but rules on how to use them.
Crucial. Strict usage rules. For example, The accent color, HEX tag F4500, must only be used for primary button elements with the CSS class.cda-primary and for text links on hover. This prevents the AI from getting creative and splashing the accent color everywhere, diluting its impact.
And for typography, similar constraints.
Same idea. Limit the AI to maybe 2, maximum 3 font families to ensure consistency and also help with performance loading fewer font files. More importantly, mandate legibility standards.
Like font size.
Yes. Body text size must be specified as 16 pixels or larger. That's generally considered the minimum for comfortable reading, especially on mobile screens. And equally important is defining line spacing or line height in CSS terms.
How specific should we be there?
Mandate it. Something like line height for all body text paragraphs must be at least 1.5 times the font size. That extra space between lines significantly improves readability for longer text blocks, reduces eye strain.
Okay, clear rules for colors and fonts. Now, what about different screen sizes? Responsive design is obviously essential.
It's table stakes now, yeah. But the modern approach, the one we should instruct the AI on, is mobile-first design.
Meaning, design for the smallest screen first, and then adapt for larger ones.
Exactly. Force the AI to prioritize the core content and functionality for the mobile view, ensuring that experience is lean, fast, and focused. Then it can progressively enhance the layout for tablets and desktops, adding secondary elements or more complex layouts where space allows.
And we need to get the AI technical instructions for how to achieve this responsiveness.
Yes, mandate the techniques. Instruct it to use fluid grids layouts based on percentages or viewport units, not fixed pixel widths. Instruct it to use flexible images setting max width, 100%, and height, auto so images scale down gracefully.
And define the specific points where the layout changes.
Yes, define the breakpoints. Explicitly tell the AI, implement breakpoints at 480px, 768px, and 1544px, and crucially, specify what should change at those points. For example, at the 768px breakpoint, the main navigation menu must collapse into a hamburger toggle icon.
Okay, this all sounds good, but what happens if the AI is trying to follow a visual instruction, like using a big, beautiful image, but that conflicts with a performance goal?
You've hit on maybe the single most important instruction in this whole visual identity section, the conflict resolution mandate.
Because an AI, left to its own devices, might prioritize making something look exactly like the visual spec, even if it makes the page slow down to a crawl.
Precisely. A visually stunning theme with massive images, complex animations, multiple custom fonts. It could look amazing but be a performance disaster. We have to prevent that.
How? What's the instruction?
You state it explicitly and unequivocally in the prompt. In any situation where a visual design choice conflicts with the mandated performance target, Google PageSpeed Insight score of 90 plus for mobile, or core usability principles, performance and usability must take precedence over the visual aesthetic.
Wow, that's basically giving the strategic goals veto power over the design details.
It is. It's the safety valve. So if the AI calculates that using that gorgeous, full-width, high-resolution hero image you specified will add 500 milliseconds to the page load time and drop the page speed score below 90, but using a smaller, more optimized banner image keeps it above 90.
It must choose the smaller, faster banner, even if the original design spec showed the big one.
Exactly. It forces the AI to act like an accountable engineer focused on the overall goals, not just an artist trying to perfectly replicate a visual mock-up. That single instruction prevents a lot of pretty but slow themes.
Okay, strategy, structure, content, visuals. We've covered a lot. Now we need to define the theme's engine room, the actual functions it needs to perform, and the technical standards it has to meet.
Right. And this starts with thinking about the person who has to manage the site long-term, the administrator. So we need to define theme features and customization options.
This is about giving the site owner control without needing to code, right? Using the WordPress customizer or maybe block editor settings.
Exactly. The prompt needs to list every single customization control required. Don't leave it to chance. For a classic theme using the customizer, this might mean specifying, provide 3 distinct layout options for the site header. Banji, logo, left nav right, logo centered, logo left nav below. Or include color pickers in the customizer for the primary brand color and the accent color. Or add toggles to show hide post metadata, like author, date, category on archive pages.
Just listing them isn't enough, though, is it? The admin interface itself needs to be organized.
Crucial point. We need to define the admin UX structure. If you just list 50 controls, the customizer, or theme settings area, becomes an unusable mess. The prompt should specify the hierarchy.
How would that look?
You define the customizer panels, which are the top-level containers. Example, create a main panel called theme settings. Then define sections within those panels, e.g. inside theme settings, create sections for header options, blog layout, footer settings, and then specify which controls go into which section. This forces the AI to build a clean, logical, and maintainable back-end interface.
Okay, good admin controls. Next big thing in WordPress is plugins.
Oh yeah, critical plugin compatibility. A theme isn't built in a vacuum. It has to play nicely with the essential tools people use. A beautiful theme that breaks when you activate WooCommerce is effectively useless.
So the prompt needs a list of plugins that are non-negotiable.
Absolutely, and specify the level of compatibility. Top of the list is usually WooCommerce. You need to demand 100% compatibility. That doesn't just mean it doesn't crash. It means the theme must provide seamless, consistent styling for all WooCommerce elements, product pages, shop archives, cart, checkout, account pages. The styling should match the rest of the theme perfectly.
What else is usually critical?
Compatibility with major page builders like Elementor, Beaver Builder, or maybe the core block editor itself, if that's the intended workflow. The instruction needs to say, ensure theme styles do not conflict with Elementor's controls and output, and support Elementor's theme builder functionality, allowing users to override theme templates like header, footer, archives with Elementor templates.
So the theme needs to be flexible enough to let builders take over parts of the design.
Yes. And then you usually need compatibility with leading SEO plugins like Yoast SEO or All-in-One SEO, making sure the theme correctly implements things like title tag support so the SEO plugin can control the page titles. And compatibility with major forms plugins like WP Forms or Gravity Forms is often essential too. Basically, the AI needs to use standard WordPress hooks and filters so these core plugins can function as expected.
Right, makes sense. Beyond plugins, there are fundamental quality standards the theme just has to meet. Performance, SEO, accessibility.
These aren't optional extras. They are foundational technical standards. And again, we need concrete, measurable targets for the AI.
So for performance, what kind of metrics should we demand?
Be specific. Demand a Google PageSpeed Insight score of 90 or higher, specifically for the mobile test. That's a high bar, forces optimization. Mandate a total page size under 2 MB for key templates on initial load. And specify a low number of HTTP requests, maybe fewer than 30. These give the AI clear performance budgets to work within.
Okay. And for SEO, beyond plugin compatibility.
Mandate the use of semantic HTML5 markup. Tell the AI, use appropriate HTML5 elements like header, footer, nav, main, article, aside, instead of relying solely on generic div elements. Also, enforce a logical heading hierarchy. Ensure each page contains only one H1 element used for the main content title, followed by a logical sequence of H2, H3, etc. for subheadings.
And accessibility. We touched on contrast earlier.
Yes, but it's broader. Mandate adherence to WCAG 2.1 level AA standards as the minimum baseline. This is the widely accepted standard for good accessibility. For the AI, this translates into concrete instructions like ensure all interactive elements, links, buttons, form controls, are fully navigable and operable using only the keyboard. And all form inputs must have programmatically associated label elements for screen reader compatibility.
These standards seem crucial for a professional build. Now, you mentioned the template hierarchy bridge earlier.
Yeah.
Is there a higher level version of that, the ultimate technical instruction?
Yes. We called it the technical linchpin, master template hierarchy mapping. This is where everything comes together, ensuring the entire theme structure respects WordPress core logic. It's probably the single most critical technical specification to prevent a fundamentally broken theme.
What does this master map involve?
First, the prompt must make the theme type declaration right at the start of this technical section. Tell the AI explicitly, this theme must be developed as a classic theme, using PHP-based template files and leveraging the WordPress Customizer API for options. Or alternatively, this must be a block theme, utilizing theme.json for configuration and relying on full site editing principles. That single choice dictates the entire underlying architecture.
Okay, declare the theme type. Let's assume we chose classic theme for this example. What next?
Then you mandate the required file structure. Specify the essential root files .style.css with the theme header, index.php, the final fallback, functions.php, and specify how assets and template parts should be organized, e.g., all CSS files must reside in assets, JavaScript in assets.js, and reusable template fragments, like header or post content, in a template parts directory. This enforces clean organization.
And in the map itself, linking views to files.
Exactly. This is the detailed mapping table it needs columns for. View content type, e.g. news category archive, specific condition, AG category archive where the category slug is exactly news, the required template file name the AI must create and use, category-news.php, and finally, key logic elements required in that file. AG must display posts in a compact list format showing only title and date, no excerpts or featured images.
So this map covers every single view the sitemap defined earlier.
Ideally, yes, or at least all the views that require a template file different from the standard WordPress fallbacks, like index.php, archive.php, single.php, page.php. If you don't define this map, the AI is essentially guessing the theme's internal architecture. If you do define it meticulously, you remove almost all architectural ambiguity, guiding the AI to build a clean, correct, and fully WordPress-compliant theme structure. Failure here is catastrophic. Success means a working product.
Okay, we spent a lot of time defining the perfect set of instructions, the strategic, structural, visual, and technical blueprint for the theme. Now we need to shift focus to the AI itself, the agent that's going to execute this plan.
Exactly. We're moving beyond just writing a good prompt to actually engineering the reliability of the agent. This means understanding the agentic paradigm.
What does that mean in practice? How is an agent different from just, say, a code completion tool?
Well, the AI agent isn't just passively waiting for instructions. It's designed to be a proactive collaborator. The research defines these agents by 4 key characteristics. Intentionality, it has a clear goal given to it. Forethought, it plans out the steps needed to achieve that goal. Self-reactiveness, it can monitor its own progress and react to errors or unexpected results. And self-reflectiveness, it can evaluate its performance against the goal and adjust its plan.
So it's more like hiring a junior developer who can think for themselves rather than just using a fancy autocomplete.
That's a good way to put it. And the engine driving this is typically something called the REACT loop, which stands for reason and act.
How does that loop work?
It's an iterative process. First, the agent reasons. It analyzes the overall goal, our detailed prompt, consults any rules or memory it has, we'll get to that, and formulates a step-by-step plan. Then it acts. It chooses and executes a specific tool. Maybe it needs to use the terminal to run a build command, or file read to check existing code, or file write to generate new code.
Okay, reason, act, then what?
Then it observes. It processes the output or result from the tool it just used. Did the command succeed? Did it throw an error? What does the file content look like now? And based on that observation, it loops back to reason again, figuring out the next step. It repeats this cycle, reason, act, observe until the overall goal is achieved.
And this loop is what allows us to give it higher-level instructions.
Precisely. It enables the declarative paradigm. Instead of the old imperative way, write a function that takes argument x, performs calculation y, and returns z, we can give it a declarative goal. Refactor the user authentication module to improve login performance by at least 15% while maintaining existing security standards. The AI uses its REACT loop to figure out how to do that procedurally.
And having a large context window, like with Gemini 1.5 Pro, is important here.
Absolutely essential. The large context window allows the AI to reason over the entire code base, or large parts of it, not just tiny snippets. This is critical for tasks like architectural refactoring or ensuring consistency across the whole theme. You can see the bigger picture.
Okay, so these agents are powerful, capable of complex reasoning and action, but autonomy can be dangerous if it's not controlled, right?
Exactly. Autonomy without guardrails is just chaos waiting to happen. To make these agents reliable and predictable, especially in a team or production environment, they must be governed. This is where the governance pillars come in, translating our team's policies and standards into actual code constraints for the AI.
What's the foundational piece of this governance?
It's often a configuration file, something like Gemini.md in the Gemini system. Think of this file as the agent's persistent constitution or rulebook for a specific project. It's where you put project-specific instructions that override the AI's general training. Things like, always use tabs for indentation, never use deprecated function X, all CSS class names must follow BEM naming conventions, or API keys must never be hard-coded.
And this file applies across sessions. It remembers the rules.
Yes, it provides persistent memory. And importantly, it often supports hierarchical context management. This means you might have a global Gemini.md with company-wide rules, a project-level one with specific tech stack rules, and maybe even .gemini files in subdirectories for highly localized instructions.
So you could have a general security rule, but maybe relax it slightly within a temporary build folder.
Exactly. It allows for very nuanced, context-aware policy enforcement. It's quite sophisticated.
Beyond this rulebook, can we enforce specific workflows more actively.
Yes, through custom/commands. Think of these as reusable, named shortcuts for complex, policy-driven prompts. Instead of a developer having to remember a long, detailed prompt every time they want the AI to perform a standard code review, the team can create a command like review.security_audit.
And running that command triggers predefined multi-step prompt.
Right. A prompt that maybe instructs the AI to check the modified code against the OWASP top 10 vulnerabilities, verify compliance with internal coding standards stored in Gemini.md, and generate a report. It makes complex, required workflows easy, repeatable, and auditable. It's policy as code in action.
Okay, that makes sense for development.
Mhm.
But what about when these agents start interacting with deployment pipelines? CI/CD. Security must be paramount there.
Absolutely critical. If an AI agent is automatically committing code or triggering deployments, using static API keys or secrets is just too risky. They can leak, they expire, they're hard to manage. The modern solution here is Workload Identity Federation, WIF.
That sounds complicated. Why does someone writing the prompts like a project manager need to care about WIF?
They don't need to know how to implement WIF, but they need to understand why it's essential so they can ensure their technical and security teams mandate it. Why basically eliminates the need for the AI agent or the CI/CD runner it operates in to store long-lived static credentials.
How does it work conceptually?
It establishes trust between the platform where the AI is running, like GitHub Actions, GitLab CI, etc., and the cloud service it needs to access, like Google Cloud, AWS, Azure. The CI platform issues a short-lived, cryptographically signed token, an OIDC token, that essentially says, I vouch for this workload. The AI agent presents this token to the cloud service. The cloud service verifies the token with the originating platform and, if valid, grants temporary, scoped credentials back to the agent.
So no permanent keys stored anywhere, just temporary handshakes.
Exactly. It's keyless authentication for automated workloads. Much, much more secure. It's becoming the standard for secure automation.
Okay, security handled. What if the agent does something unexpected, maybe introduces a subtle bug? How do we trace back why it made that decision? We need an audit trail.
Absolutely. That's where auditability comes in, often using provenance frameworks. The example given in the research was ProviAgent.
What does something like ProviAgent track?
It's designed to capture agent-centric metadata. It logs the exact prompt the agent received for a task, the internal reasoning chain the AI model followed to arrive at its plan or solution if the model exposes that, the specific tools it called, file write, terminal, etc., the parameters passed to those tools, and the results observed.
So it creates a complete step-by-step log of the AI's thought process and actions.
Yes, an unimpeachable ledger. This is invaluable for debugging when things go wrong, for understanding how a particular piece of code came to be, and potentially for compliance purposes if you need to demonstrate how automated processes are working.
This all sounds incredibly powerful, but also risky. What are the potential downsides of relying so heavily on these autonomous agents?
The research highlighted two major systemic risks we need to be aware of. The first is called epistemic fragility.
Epistemic. Knowledge-related fragility. What does that mean?
It's the danger of a closed cognitive loop. Imagine the AI agent writes the application code. Then, the same AI agent writes the unit tests for that code, and then maybe it even performs the code review, checking the code against the tests it wrote.
I see the problem. It's grading its own homework.
Exactly. The entire verification system becomes self-referential. The AI might introduce a subtle flaw in both the code and the test, or misinterpret a requirement consistently across both. But because everything aligns within its own logic, all signals report green. The actual connection to ground truth degrades the system's knowledge, becomes fragile, but the internal checks don't detect it. This is sometimes called epistemic drift, and in severe cases, epistemic collapse.
Okay, that's a scary thought. What's the second major risk?
This one might feel more familiar. Cognitive debt. It's the potential atrophy of the human developer's own critical thinking skills and deep system understanding because they're over-relying on the AI to do the heavy lifting.
It's like using GPS all the time and forgetting how to read a map or even navigate your own city.
That's the perfect analogy. We become incredibly efficient at following the AI's directions, but we lose the underlying knowledge of the system's architecture, its quirks, its history. Then, when the AI fails, maybe it hits a complex edge case it wasn't trained on, or encounters a legacy system, it doesn't understand the human team is left brittle. They lack the deep intuition needed to diagnose the problem and fix it effectively.
So how do we mitigate these two big risks? The AI marking its own homework and the humans forgetting how to think.
The primary mitigation strategy discussed is implementing a mandatory human-in-the-loop (HITL) model, especially for critical or potentially destructive actions.
What does that mean in practice for the AI agent?
It means the AI must be constrained. Before it executes certain types of actions like modifying a core configuration file, running a shell command that could delete data, rm-rf, merging code into the main branch, or deploying to a staging or production environment, it has to pause.
Pause and ask for permission.
Yes. It must present the proposed action to a human developer and request explicit approval. The interface usually offers options like approve, let the action proceed once, deny, stop the action, or maybe always trust this specific type of action from now on, use with caution.
So this acts as a safety gate.
Exactly. It prevents runaway agent behavior, but just as importantly, it forces the human developer to stay cognitively engaged. They have to review what the AI is proposing before it happens. This breaks the closed epistemic loop because you have external human verification, and it helps combat cognitive debt because the human is constantly seeing and validating the AI's work, keeping their own understanding fresh.
That seems like a crucial safety layer. Is there anything else to help manage the risk, maybe when things just go wrong during development?
Yes, there's a really neat architectural feature mentioned, the restore command, or similar checkpointing functionality.
How does restore work?
Imagine a developer is working with the agent on a complex refactoring task. Maybe the agent starts going down a weird path, or the results just aren't quite right after several steps. Instead of manually trying to undo all the changes, the developer can issue the restore command.
And it just rolls everything back.
It instantly reverts all the file modifications made by the agent during that specific task or since the last checkpoint, restoring the code base to its previous known good state.
Wow, that sounds incredibly useful. It lowers the stakes of experimenting.
Precisely. It dramatically lowers the cost of failure. When developers know they can instantly undo any changes if the AI's approach doesn't work out, they feel much safer tackling more ambitious, complex, or potentially risky refactoring tasks with the agent. It actually encourages innovation by making experimentation cheap and reversible. #outro.
Okay, we have really covered a lot of ground here, taking a deep dive into crafting that ultimate prompt for an autonomous AI developer.
Yeah, it really seems clear that getting a high-quality, professional, and genuinely strategic WordPress theme built by AI requires tackling two distinct but parallel challenges with real rigor.
What are those two tracks again?
Well, first, you need that incredibly meticulous specification. The strategic blueprint, the UX architecture, the visual rules, the technical standards, everything we covered in parts 1 through 4. That's about translating abstract needs into concrete, unambiguous instructions for the AI.
Turning the what I want into exactly how you must build it.
Right. And the second track, covered in part 5, is about engineering the cognitive partner itself. Building a robust framework to govern the autonomous agent using policy as code like Gemini.md and / commands, ensuring security with WAP-UOF, maintaining auditability, and implementing crucial safety features like human-in-the-loop approvals and rollback capabilities.
So it's spec the job rigorously and govern the worker rigorously.
In essence, yes. The entire framework we've discussed, from deeply understanding the user's pain points all the way to mapping the specific WordPress template files, it's all basically a sophisticated defense mechanism.
A defense against what?
Against the inherent non-determinism and potential unpredictability of large AI models. By providing such a detailed, unambiguous blueprint and wrapping the agent in strong governance, you drastically reduce its freedom to improvise or make suboptimal choices. You essentially force the intelligent agent to follow a predictable, defined procedure.
Transforming it from perhaps an unpredictable oracle into something more like a highly reliable, policy-driven collaborator that executes precisely according to your strategic vision.
That's the goal. You're engineering trust through meticulous specification and robust governance.
It really puts the emphasis back on the human input, doesn't it? Which leads to a final thought for you, our listener, to maybe mull over. If the quality of anything an AI generates, code, text, images, strategy, is ultimately directly proportional to the rigor, depth, and strategic insight of the prompt you give it, what happens to the value of human expertise when perhaps the most crucial skill left is simply knowing how to ask the perfect, strategically informed, technically precise question? Something to think about as you maybe start drafting the first line of your own master prompt.